Hi, everyone. This next example that we're going to see for recursion in Python is Lucas sequence. Now, if you've already done Fibonacci, this is going to be pretty simple for you because this is a sequence that's very similar to Fibonacci, at least in terms of the implementation. And the only thing that's different is that the starting numbers are 2 and 1 and not 0 and 1. And apparently, Lucas is the second most seen sequence in nature. So there's something around that there. All right, so I'm going to give you a minute and maybe you can start coding while I open up VS Code. Okay, I hope you took some time to try to write the Lucas function. Remember, we are using recursion. So I'm going to ask you to think about those 5 steps that we've talked about before and how can you use those 5 steps. So first is, of course, I've told you the parameter that we're passing here is n. This is very similar to the Fibonacci. So if you've already not seen the Fibonacci example that I did, you can go take a look. But our base case is going to be, of course, well, I'm going to write it separately because we have to return 2 separate numbers. So if n is 0, so if it's the 0th term, if you're returning term 0, I told you Lucas starts with a 2. So we're going to return 2. Simple. Okay. We also have another base case here, and that is if n is 1, right? So we do an elif, and we say if n is 1, in this case, what are we doing? We're returning term 1, which is 1. So we go ahead and we return 1. And now you can write an else or skip this. I've mentioned this before. It's optional. For clarity, I'm going to write an else. So if the term is not 0 or the term is not 1, then what are we going to return? We are actually going to return one term. We're going to call the function. So we've done the base case, we've determined the condition. Now we're doing our sub problem, right? So we've already checked against the base case. We've checked n against the base case, and now we're calling our recursive case. So the recursive case is when n is greater than 1, we need to call Lucas on n minus 1, right? Remember, the term of a Lucas sequence is nothing but the sum of the previous 2 terms. So we're going to try to find the previous 2 terms. So in order to find the previous term, we're going to do Lucas of n minus 1. And in order to find the term just before that, we're going to actually call Lucas on n minus 2. Okay. This is all we got to do. Now let's call the function. Let's see if it works. So I'm going to print it. And I think the example that we were given is Lucas of 5. And we want that to be 11. I'm going to run the code. And you'll see that it did return 11. Okay, I hope you're able to do this on your own and try it out. If you have any questions, just let me know. Okay, bye.